Hello, everyone.
Hi, Shannon. How are you?
Go on, Maddie. How are you?
I'm doing well.
Shannon.
Hi, Ruth. How are you?
Good, good. How are you? Good weekend and all that?
Yeah, it was really good.
Awesome.
Very good.
Hello.
Oh, there we are. Hi.
Hi. Can people hear me?
Yep, I can.
Good. Hi. Too many screens open, but I'm in. Okay. How's everybody?
Good.
I'm
Everybody
Randy
doing
with
well?
Glass Art. I see some.
Hey, Alana.
Nice.
Hi, Shannon. Hello, everybody.
How you doing, Alana?
Living the dream.
Awesome.
Oh,
Are you feeling good, Alana?
yeah, yeah. Crazy busy right now, oh my gosh. Sure it is for everybody.
Everybody's nodding.
Mm-hmm. Yep.
Yeah.
Hi, Leanne.
Hi.
How are you?
Sorry, I'm
Okay.
listening. I got it on mute. A lot going on around here, but I'm good. Yeah, we're busy. It's crazy busy. It's good though.
Crazy busy. I'm like, I need 5 more of me.
Mhm. Yeah. Yep. But
Good
all
to
is
hear.
well. All
Yeah.
is well.
Can't complain, right?
Can't complain.
Busy,
Yep.
super good.
Yep. Busy is good.
Ah, I see it.
Mike, I can't see you. Are you on a different screen? What? I can't see you.
Nope, I'm here. I'm just getting ready to share my screen.
Oh,
You don't want to
okay.
see me.
I see your dog,
Yeah, it's my
Oh.
assistant Gibson.
Gibson.
Oh.
Oh,
Yeah, he's
I love dog cameos.
yeah, he's helping.
Oh, so
Hello.
cute. How old is he now? Michael, how old is he now?
He is 4.
Really?
I like it when he sits in here with me behind my chair though, so then he doesn't bark because he, of course, needs to talk to everybody who walks past the house.
Mm-hmm. I see.
Yeah, if I mute, it's probably because I have a barking dog.
Yeah,
so.
same here.
Mhm.
Fun.
Okay.
It's nice to see faces without masks. So,
Yes.
even if
Mhm.
we're like this, yeah.
Cool. Well,
Zoom is.
it looks like you got people showing up, so we should get started. First, I wanted to say thank you to everybody for coming in today. This is Nari's first one of these, so this ought to be fun.
Cool.
We do want to thank our quarterly media sponsor, which is Minneapolis St. Paul Home Tour. Thanks to them for doing what they do. Also, after the presentation, at some point you will be getting a survey. So please watch for that and share that with us. That would be great. And before I get started, I would like to introduce Alana Wynn and allow her to say hello and give you all a little greeting.
Hi, everybody. I am Alana Wynn. I'm the current NARI 2021 board president. I almost said 2020. I'm still stuck in that year. Looking very casual right now, so sorry for the sweatshirt, but yeah, this is our first LunchBox hour, so thanks to everybody for coming. And I just wanted to echo what Michael said in regards to the survey. It's really, we really use those to change or continue the offerings that we have for membership. So please do fill that out after the event today. That's all I got.
Cool. Thanks, Alana. I'm going to see if I can get this thing to work, and it should. There we go. Hopefully everybody can see my screen.
Yeah.
Awesome. Well, let's get this thing rolling. This is everybody's favorite subject ever in remodeling, especially obviously around kitchens, which is ventilation 101, as I call it. This came about from just my experience, 30 plus years in the kitchen industry, and luckily having enough experience to have learned on almost all ends the pluses, the minuses, how ventilation works, how all hoods work. And over the years, I've found it can be a bit contentious, especially where we are. So given that, by the way, if you're looking, this is an accredited CEU. So if you ID CEC, let me know. I can log that for you. You can also log this and self-report for NKBA, AIA, or anything else. This is a special version though, because as I said, with my experience, both all the way to globally, but Minnesota, we are in one of the most unique areas in the world for how we get to deal with ventilation. So I'm subtitling this the Minnesota edition. So hopefully I can cover some things that are pretty unique to our area as well. And this is what I'm hoping you come out the other end of this with: a basic understanding of how kitchen ventilation works. Hopefully when you look at a hood after this, you might be able to start to break down how you can expect it to work, because they're all a little different. The consequences of where you put the hood and whether or not it's installed properly are also important to know. And then in general, the overall impact having ventilation that's good can have on a successful kitchen project. And when I say that, I mean, not just on the day it's done and it looks beautiful. 3 years down the road, we want people to be loving their kitchens and saying great things about it. So this is my thing. What is our duty when we're talking to clients and we're meeting their expectations? Are we meeting their expectations? What does that mean? There's a lot of different roles in this. There's the architect. It starts with how you plan out the whole thing. It might be the kitchen designer. Certainly a remodeling contractor is going to have a lot of input. New home builders, appliance sales consultants play a role because they're usually having that conversation about what everybody's putting in. And really the HVAC guys come into play in this too, because they're quite often looped in, especially on a new home, with everything around ventilation. And so they do get kind of pulled in, maybe just for the install, but they get pulled into the kitchen too. And what obstacles do we have to work around to meet and really hopefully exceed the expectations of our clients? I think that's really important to think about. And there are obstacles everywhere. Again, Minnesota, we do have some extra ones, so we're lucky that way. Love this guy's thought here, because design isn't just what things look like, especially in a kitchen, because they do things. So it's also how things work. Never been more true than when we talk about kitchen ventilation. And I like starting with this because this is something nobody really has said ever, probably, that people really value kitchen ventilation. And they're used to having kitchen ventilation that really works. You know, they're cooking bacon and fish. They don't smell it anywhere. They love it. It's great. Yeah, nobody ever says that, because this is the reality. This is the world they're used to living in. It's crazy. But if it's done properly, ventilation solves a problem, and that problem is air quality. And for this, I'm going to pretend, let's all pretend we don't live in Minnesota, and specifically we don't live in the Twin Cities, because a lot of this is just ventilation to get it to work well, regardless of where you are. And I'm going to go basic. What is a range hood? Wikipedia is always helpful for this kind of stuff. I mean, this is a basic explanation of what a range hood is. Really, it's the last sentence on that first paragraph is it, that it's there to make sure that we get everything out of the house that we don't want. And there's some bad stuff in there. There's actually, Berkeley is doing a lot of work on air quality in the homes out in California. And in addition to that, others have looked at this over the years. This is something I pulled out of something in the New York Times. And as you can see, homes these days, and this is overall, this isn't just kitchen, it's not good. You know, we're building homes so tight, a lot of times we're keeping a lot of things in that we do not want to have. And this is what they're finding out in California when they've done the research and they've taken the readings. The pollutant levels are illegal if they were outside. So air quality is an issue. I think it's going to become more and more of an issue as we go through time. Eventually, we're probably going to see more requirements on what you do in a home to handle the overall air quality. And again, not just in the kitchen, but if you cook a lot and you don't use your hood, or it may not be effective, you're going to have a big problem, because you're going to be really adding a lot of pollutants to your home from cooking. Berkeley is finding, obviously, the kitchen is probably the biggest offender, as they put it, of reducing the air quality in the home. So what is the purpose of cooking ventilation? This is it very specifically. We want to increase the air quality in the home by pulling the contaminants out before they mix with the rest of the air in the home. And what are they? This is what we're working with and what we want to deal with. This is the problem we want to solve when we're in the kitchen. We want to get the heat out. We want to get rid of the steam, because that carries things around the house. Smoke, obviously, we would rather not have smoke all over the house. Gets loud because all the smoke alarms go off, for one. Really don't want the fish and bacon we cooked to smell in our bedrooms, probably, or the living room, or the basement, or in some cases, all the way in the garage. We also, if there are any hazardous gases coming off, we want to deal with those. Even when you burn food, it does produce hazardous chemicals that are lung irritants. And of course, if you have gas cooking appliances, there are some off-gassing that those are doing. And we also want to deal with the grease. The grease is one thing we do want to collect and capture so that we can clean it out. All of the other things on this list, we really would like to remove from the home. And a good place to start when you think about this is, traditionally people will start with what is the cooking equipment. That plays a very important role, but the ventilation equipment is just as important as the cooking equipment, because it's going to give you that quality of experience when you're actually cooking in the home. And in ventilation, I've broken it down to 4 basic types or categories of ventilation. We've got what I would call ductless hoods or recirculating hoods. These aren't super helpful because they don't really remove anything. They just recirculate the air through them. Downdrafts are something that came out in probably the 80s. Genair and Thermador started those. Some of them will pop up in the back. Some of them will be actually built into the cooking equipment. Most of the hoods that are out there are hoods with filters. So they use some sort of filter bank. And that's what we'll talk about in a little bit on how that helps us handle grease. And there is a small group of hoods that use a centrifugal blower system. So how are we going to get there? How are we going to get effective ventilation? When we look at the system, it is a ventilation system, and there are 3 main components. And for most of what I'm talking about, we're going to not address the recirculating because that pulls out a big part of this system that's important, which is the ductwork. So we've got a canopy. That's usually the thing you're going to see. Blower units, something that moves the air around, and it's going to be connected to ducting, hopefully good ducting that will take everything to the outside. So the canopy, that is the part you see. Very visual. Sometimes somebody else builds the canopy for you, even though there's a hood up inside of it. You can see it in the bottom center. That's kind of a newer addition to ventilation called a parametric style hood. And those are intended to go very flat up in the ceiling. We're also seeing them show up in some finished hoods too. Some hoods will have what they call duct covers, which is what you've got in a chimney. Oh, looks like somebody's got their mic on. They're frequently attached to the canopy, as you can see on the left. That's what we would call a chimney style hood. But sometimes on wall hoods, they'll also put a duct cover up. It's really aptly named because it covers up the ductwork, so you don't have to look at it. So what part does the canopy play in this getting effective ventilation? Well, its intended purpose is to collect the natural rising gases and heat and byproducts generated by the process of cooking, heating, and cooking food. A big Cliff-Clavin nugget. You just cook 1 day a week, you're going to generate a gallon of grease per year, and it goes somewhere. But the canopy is a collector. Think of it as an inverted bucket that is up over whatever your cooking equipment is, and it's up there waiting to get filled up and to collect all of this nasty stuff we're making. Well, some of it smells good, but especially the nasty stuff, we're going to collect that up. And really to think about how this canopy is going to work and help us, it's really important to understand and think about what's happening when you cook. Again, we're experiencing this quite frequently. We're generating quite a problem. And part of the problem is what we're cooking on is creating heat and steam. And what happens with that is it expands as it goes up. That's why that collector is very important. If we get it too far away, it's not going to be able to collect. In a perfect world, and what most ventilation manufacturers want is they actually want the hood to overlap the cooking equipment by 3 inches on each side. That is what most every hood manufacturer would like to have. Of course, frequently that doesn't happen and we just match it up. We certainly, over a 30-inch piece of cooking equipment, we'll put a 30-inch hood. If it's 48 inches wide, we'll put a 48-inch hood. Bear in mind, if you can, overlapping is always preferred because it's going to work better because this stuff doesn't just go straight up. It expands as it rises. And this is why that's important. As things go up and go out, we need that hood to be able to catch them, because if it gets outside of the hood, although hoods move air and some would say hoods suck, they don't really suck. So once it's outside of the canopy, it's not going to pull it back in. Even if you have a big roaring 1500 CFM blower, it's not going to pull something from out in front of the hood back into it. So we like to be able to overlap as we can. The projection is also very important. And certain hoods are manufactured specifically for certain types of cooking equipment. For example, a hood that is designed to go over a cooktop drop-in cooktop is the projection will be less because it doesn't have to stick out as far. Whereas if you look at pro hoods that are expecting to go over a big 48-inch pro style range, their projection is going to be deeper. And again, just like the overlap, we really want to be able to cover as much of the cooking area as we can so we don't let anything escape. Mounting height is crucial to this, and all hoods are going to be engineered to operate at a specific mounting height. It might be 24, 27. A lot of pro hoods are going to be mounted at 30 inches. Some will say you can mount them up at 36 inches high. However, if pressed, the engineers who made those hoods will admit it doesn't work as well up that high as it does down lower. 30 inches is pretty much the standard recommendation, particularly over pro style cooking. And again, the hood's going to be engineered and give you information on that. You can find that frequently from the hood manufacturers. Here's some examples. It will also tell you what some of them are a little bit more static. Capacity is important. This is why that mount oriented correctly, sized correctly, be really important, especially when we get to the more aggressive style of cooking, like pro cooking. That's why you'll see pro hoods tend to be deeper, whereas hoods that might be engineered to go over a cooktop might be 6 inches high, might be 9 inches. Pro hoods are going to be 18 inches. Some of them are even 30 inches. So bigger bucket, more holding capacity. And to be fair, mounting heights are frequently viewed as very arbitrary, very aesthetic. And also, it's the client's hood. If they want to put it at 38 inches, they can put it at 38 inches above the cooking surface. Most of the mounting heights are recommendations and stated as such. Part of the reason is with hoods, there's no real performance guarantee from most manufacturers. They really aren't equating directly where they're installed to how they're going to perform. But you want to look out because there are some out there that do have a guarantee, and for them to work, they will say very upfront that mounting height is really critical to ensuring the hood can do what it's expected to do. And just here's a layout of a bunch of different style hoods so you can see how the mounting heights will vary. And these are all for different styles hoods that are intended to go over different products, different applications. Wall mounts down on the bottom are some islands. So you can see it ranges quite a bit, like I was saying, from that 24-inch up to 30 inches. And where are they going to go? There's a lot of different installations of hoods and where they go in the home. Kind of going left to right. Wall mount is what you're going to see. The chimney style hood, as you can see in the picture there, that's what that looks like. A lot of pro hoods are considered wall mounts. So literally the hood's going to mount on an exterior wall, maybe an interior wall, but they're going to mount on a wall. Island is the next one. Those are really hard. Ventilating an island cooking application is a very difficult thing to do because air moves around so much that it can really pull those things out of the capture area of the hood. Corner, I haven't seen very much lately. I think most people would agree it's quite a waste of space. I think it was a thing about 20 years ago, saw more of those. Don't see the corner very much anymore. The built-in is going to be also referred to sometimes as a liner. And that's where from standing in the front, you're not going to see the actual hood, the canopy itself. Cabinet maker is going to make something traditionally that will match the cabinetry around it. And the functional part of the hood is built in up inside of the cabinetry. There are some new ceiling hood fans. Those are those real flat ones that you'll see. It's a parametric hood. The idea there is it goes all the way up in the ceiling so you don't have to see anything. Hopefully our cooking products will get up there for it to pull out. Under cabinet hoods is what you're going to see frequently over a standard, maybe a standard 30-inch range. Those frequently are 6 inches tall. Some of them are 9. Those literally install and mount under the cabinet. And then of course there's the downdrafts. Those are going to be, most of them are something that pops up behind the cooking product and then can be placed back down so you don't see it. Again, it came from wanting to put cooking in the island, but not wanting to have a hood drop down over it. It's kind of where they came from. Those are out there as well. The hood location is important because apparently this person was wondering if there was a problem with where their hood was because it didn't seem to be working very well. I have seen this happen as well, where a hood will get centered over an island because it looks better, and it is not paying attention to where the cooking product is at all. Obviously, this is not going to work very well. So the canopy is the part that you see. There's a subset to that I mentioned a minute ago, the built-in. Some will call them liners, inserts, or power packs, various kinds of those out there. Some of them, as you can see, they will show just built right into cabinetry. The second picture and from the left is what some manufacturers call the liner that goes with the power pack, because it provides a stainless steel shroud basically that will cover combustible materials that are around the power pack. This is another kind of subset, and that's parametric hoods, which are new. They're probably the newest subset. And again, their intent is to allow you to get something way up in the ceiling so that you don't have to have anything drop down, and they're going to purport to collect the cooking vapors and byproducts that get up towards the ceiling. However, they are similar to filtered hoods because there are filters in them, and that's basically the idea. The benefit to this that's perceived by most clients is it looks very nice. As you can see, KitchenAid's doing quite a few of these now, for example. Looks really clean, really easy flat area to wipe out. You do need to pull that down occasionally to get at the filters, which need to be cleaned. Haven't really heard how well that works when, like up in the upper right corner, you've got one in a 10 or 12 foot ceiling. Kind of hard to get up at them, but you're going to need to do that. And when you look at all these hoods, you think about what the capture area is, what is the holding capacity. Again, we want to get things, of course, to cover what we're cooking. But when you think about an upside down bucket, how much are we able to collect? Because some of them are going to be very open. Most of them are going to be very flat. You can see the over the range microwave really has zero holding capacity. It's just completely flat on the bottom. And most hoods, because they look nice this way and they're easy to clean off the surface at least, are going to be very flat. So they're going to be determinant upon air movement to be able to collect, since they're really a flat bucket. Here's an example of what I call extreme capture area. This will come up once in a while. People go, well, what do they do in pro kitchens? You can see in a commercial application, the hood actually comes back over where even the chef is standing. Most of what these ventilation systems are there to do is to remove heat, because it can get very, very hot in a commercial kitchen. So they're dealing with the heat that's getting put up off of all this cooking equipment. 95% of the hoods that are out there are going to use filters. So given that, and that's what you'll see in most of the photos that I showed you a slide or two back. Most of them are going to use a filter bank. What that's there for is to catch the grease, because when we look at what we want to deal with, this problem we have in the kitchen, we want to get rid of those top things. The grease is the one thing we really want to capture and put somewhere where we can clean, because we really don't want the grease to go up and down our duct run. We also don't want it wandering around the house and getting into our couch and on our kitchen cabinets, which most homes, it's, if you go reach up to the top of your cabinets, you're going to feel quite a bit of grease up there. And the idea with a filter is we're going to take the air and make it move from one side of the filter to the other. Air will find its way through if we're making it move, but the grease particles are heavier, so they're going to stick to something. So the idea and the hope is, as these contaminants are rising up from where we're cooking already using the heat that's there, we'll help them a little bit. And if we can speed them up fast enough, the air will make it through the filter and hopefully we'll catch some of the grease particles. The issue with that is, as it does its job, it does lose efficiency. That's why it's important to clean your filters, most of which you can just put in a dishwasher. But as they fill up, then what can happen is the air can't move through it and it starts kind of bouncing off, and then it wanders back out and goes back into the room. Some filters are have a little bit more space to them. They're going to have a larger mesh to them. The plus is they're not going to be as loud, because when you move that air through basically a screen, it really can generate quite a bit of noise. The problem with the larger mesh filters is if you don't move the air fast enough, that grease wanders right through there and then goes to what's ever behind that and then into the ductwork. You're going to see these types of filters frequently, the mesh filters, in something like an OTR, and you've probably seen these before. You're also going to find filters in the downdraft systems. They're going to have some form of filter line back in there. Again, these parametric style hoods, when you pull that nice stainless steel panel down, what's back behind there, again, are filters. The idea with these are when the air speeds up going around that perimeter, by speeding the air up, it moves it a little faster. It's still going through the filter. Remembering, we need to move the air fast through the filter for it to be able to get the grease to fling off of the airstream. You'll also see a lot of baffle hoods. Now, these predominantly are going to be lined with pro style cooking. A lot of people like these for the look because it does say commercial, because again, that's what you're going to see in a commercial kitchen. Bigger reason you see those in commercial kitchens is you can clean them. They're stainless. They can be sanitized. They have to take them down and they steam clean them regularly. And the idea with a baffle filter, much like a mesh filter, is we're going to make that air make a couple turns. And if we can do it fast enough, the air will move through, but we're going to hold on to the grease. Like the larger mesh filter, the problem is if you're not hearing the air move through them, because let's say you have a fan that can run very slowly. The nice thing is it's not loud, but that grease is staying in the airstream and it's going to migrate right on through there. A low setting on this is going to be fine. It's probably going to get steam. It's going to catch that. If the hood fan is running really low, so it's very, very quiet, I also say it's good for sneaking a heater in the kitchen if you're going to do that. But with any filter system, you're going to need to move the air at a high velocity for it to be able to pull the grease out of the airstream and capture it in the filter, be it mesh or baffle. And again, if your air isn't moving fast, it's going to get through there. And in almost all cases, unless we're putting the blower, mounting it remotely on the roof, on the wall, or there's some inline blowers, and I'll go over those in a minute. Most often the blower motors are going to be behind the filter bank. So it's another reason we want to make sure the filters can do as good of a job as they're capable of, because anything that gets through them, of course, is going to go to whatever's behind there. Frequently, that's going to be a motor. And we can make the outside of the hood look really, really nice. This is a picture I got from somebody who the hood was pretty darn dirty, cleaned it up, cleaned out all the filters, looked great. However, behind it, really couldn't get at this. So there's a lot of grease that got through those filters. And that's how they work. Their efficiency at best is probably 70%, but on average, a filter is going to run at about just under 30% effective at capturing grease. So the rest of it is either going to bounce out into the room or it's going to make it through the filter itself. Here's the other one I mentioned. This one is unique to a company called Venahood out of Texas. They came up with this idea 80 years ago, and it is different than everybody else. And they call it a centrifugal blower. It is basically a centrifuge. So in this case, the blower is actually doing two things. It's moving the air, but also it is removing the grease. The idea with this is just like a centrifuge that would be used in the Gulf to pull, to separate the oil from the water, or in a medical facility where they're separating plasma for blood, they use it as centrifuge. And in this case, it creates pressure inside the box. The cooking contaminants come up into it. We kick out the bad stuff that we want to go out of the house, which is all that steam and smoke and everything. But what we pull out of there very effectively, in this case, the centrifuge pulls all of the grease out of the airstream. And the nice thing about that is it can be very, very visible, just like that grease that was behind the filters in the one hood picture. This is cooking just 6 hamburgers. So that gives you an idea of what we're working with when we're dealing with grease. Now, 6 hamburgers, cooking them in the house. Maybe I would probably do it on the grill outside. Then I don't have to worry about ventilation, but just to give you an idea of how much grease you can create and generate while cooking. That's a good visual of that. So let's get to the blowers. They are what moves the air. So they're basically an enclosed fan. And when we come to blowers, we talk about CFM, and that stands for cubic feet per minute. So you will see blowers rated at different levels of CFM. A lot of times people think that CFM is a speed. It's actually a volume measurement because there's a lot of different ways to do it. But basically what we're doing is how many cubic feet of air per minute are we capable of moving? And you'll see that CFM rating ranging from 250 CFM to upwards of 1500 CFM. Bear in mind when motors are rated as well, they're rated with no pressure on them. In other words, that they're not in something and they're also not they're not rated at pushing the air down a duct run. That does change things, but you're going to see ratings around there and they're going to be controlled in different ways. Some of them are just either on or off, just an on-off switch. Several of them, most of them will have some form of multiple speed, and it might be a click, 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 1, 2, 3, 4, slower to faster. Some of them will use a rheostat, so kind of like a dimmer switch on a light, where from the blower's slowest capability of moving all the way up to its fastest or highest CFM, you can adjust it incrementally in between there. Newer is Bluetooth because we're getting into a lot of smart appliances. There are some hoods that will operate via Bluetooth. A lot of them will talk to the cooking equipment they're over. So, the manufacturer has it built into their range so it can talk to the hood above. And again, when we're talking about moving the air, we're talking about where is it going to go? Now, we do want to vent to the outside. You always want to do that if you can at all possible, because we can't get rid of that stuff if we don't duct to the outside. Most of them, the blower is going to do just that. It might elbow right out the side of the wall, might go up through the roof. There are external or remote blowers that are on the market as well. And the idea here is we're going to move the blower noise away from the cooking area. That's why these exist. And they're going to pull the air through. Problem in a place like Minnesota, for one, it's on the outside of the house. So if anything goes wrong with it, it's really hard to get up and get at it. It's also out in the elements all the time. Things that are outside tend to wear out pretty fast. And usually it's to reduce the noise. However, when you stand in front of a hood with a remote blower, once you turn the air speed up or increase the CFM to the point it's pulling the grease out of the airstream, you're not hearing motor noise. You're hearing all this air noise. So they exist to purport to reduce the noise. In some cases, they will reduce it a little bit. I don't think they do significantly. And again, if something goes wrong with them, they're pretty tough to get serviced. There are also what they call inline blowers, which is aptly named. It really goes in the line or in the midst of the duct run. Usually it'll be put up in the attic, and they're going to pull in from the hood and then push the air out of the house. Again, this is all ducted, so we're connected to ductwork. So what about the recirculating or duct-free hoods? They're out there, and sometimes you just can't. I helped somebody the other day. They're in a condo. They have shared walls. They just can't run ductwork anywhere. So in that case, they are kind of pigeonholed into getting a recirculating or ductless hood. But if you think about it, we really want to remove these things from the home. A duct-free hood is not really going to be able to do that. It's just going to recirculate things back into the room. One plus that I will see out there from some manufacturers is that it retains moisture in winter. Well, as we've learned in Minnesota, retaining moisture in the home isn't always a good thing. If anybody's heard of mold, which has been an issue over the years as we've tightened up the homes, we've figured it out now, I think, but we really can't get rid of anything. In some recirculating hoods, they will put something in to deal with odor. They'll have a carbon filter of some kind that they'll move the air through before it comes back into the room. And that will take out at least some of the odor in the air. So when we're talking about this stuff, how are we going to decide how much CFM we should have? Apt question in the chat. Thank you. You led right into me. And again, I'm still going to pretend we're not in Minnesota because, or rather the Twin Cities. The way we're going to look at this, there's a lot of ways to do it. If you go out on the internet, there's a lot of really good, very specific formulas for figuring this out. One that everybody pretty much agrees on, it gets real easy when you have a gas piece of cooking equipment. And in essence, if you look at what's in red there, what we're talking about is for every 10,000 BTUs your equipment is capable of producing, you should have the headroom of 100 CFM to offset every 10,000 BTUs. So in this case, if we had, we add up the BTU of all the burners and it's 40,000 BTUs, that means we should have 400 CFM or higher to be able to handle that. Do people operate their cooking equipment with all the burners on? No, but the good way to look at it is deal for the worst day ever, and we're going to be covered for the rest. A lot of even 30-inch ranges, though, now are putting out a lot of CFM. They're over 50,000, and they'll have griddles in them, even just a 30-inch range. So the CFM is important, and the best way to start, because it can be a bit inspecific, but we always like to start with the cooking equipment because that will tell us a lot. If I have an induction cooktop, that's not going to be producing as much heat as gas burners, for example. And what is it? Where is it oriented? If it's a drop-in cooktop, that's going to have a different set of requirements for it versus a full-on range top, which is basically the top of a pro range. Again, in 30-inch ranges, what is the supply? Is it gas? Is it electric? Is it induction? And then we move up to the commercial style. Most of those are gas. There are some induction ranges coming in there. That does make it a little easier to ventilate properly because we aren't having to deal with, in addition to the cooking byproducts that are coming off the food that might be burning or smoking, we're not having to deal with as much heat generation as we are with even a standard electric or certainly a gas piece of cooking equipment. And here's a good way to kind of think about it. So 300 CFM is going to cover you for the most part on most electric cooking equipment that's out there. With the exception of getting something really big that, you know, a big induction top that somebody's going to be using a lot, but you're going to be able to be covered at 300 CFM for most of them. And now remember, we're not in Minnesota. So we're talking about we can ventilate however we want to. When you start getting to gas, with the ratings of most gas equipment out there now, including your standard pretty, I guess, you know, pedestrian 30-inch range, they're all 5 burners now. And even a not very expensive 5-burner gas range is capable of producing 52,000 BTUs. Certainly a lot of the cooktops have very high burners on there. That happens to be a Thermador. The middle burner that are over 20,000 BTUs just on the one burner. Certainly when we're in a range top, like you see on the right, those burners will be 15,000 BTUs each, maybe more. 600 CFM might cover some of those. But when we get to 36 inches, be it a range or a range top, now we really need to pay attention to how much we can move. When there's a griddle involved, as you can see in that range on the right, even more important, that's probably going to encourage a certain style of cooking also that's going to create more byproducts than if we're just cooking, you know, standard boiling a pot of water, something like that. So these are capable of creating huge BTU outputs, a lot of these burners. Certainly when we get up to that 48-inch size, which you'll see, you know, you look on the plan, there's that 48-inch rectangle. Well, we know that's going to be something that's going to kick out a lot of heat and encourage a lot of cooking. So we get there, and that's where you're going to see recommendations, well over 1,000 CFM, because there are even some 16-inch pro style ranges out there. We're really giving an opportunity to create a big problem in cooking, especially if you layer in a griddle and a grill. That makes it really tough. The nice thing is a lot of the cooking manufacturers help you with this. It's not just made up to sell big, expensive hoods. There's legit reasons to ventilate properly, and they will give some recommendations. As you can see here down on the bottom right, they're calling out for their 48-inch range. They recommend 1,200 CFM. You'll notice if you were to read everything under the blue ventilation requirements, there's that 100 CFM for every 10,000 BTU concept again. Although some manufacturers aren't making recommendations because they're starting to get a little bit of pushback. So they will just simply say, we recommend you use a hood. For the most part, manufacturers are going to have some recommendation. They also do use that word recommendation very carefully because if they said you must use a 1,200 CFM hood over this, your inspector would look at that and go, where's your 1,200 CFM hood? You better have one over this. They say you need it. Most importantly, or equally importantly to what you can do with the equipment and as much heat as that can produce, is what's your cooking style? That is a big impact on what recommendation one would make on ventilation. Are you a vegan where you cook or do you cook a ration of bacon a day? Everything else can be the same, but that cooking style, these two people are going to have significantly different ventilation requirements and based on how they cook and what they cook. Remember, if they do cook a lot and they have a griddle or they have a grill, this was how much grease you get out of 6 hamburgers. If we're cooking a lot of stuff like that, we want to be able to capture that stuff and keep it. The blower is going to help us with that. Now let's get to the ducting, because this is frequently the point where you do everything right, you get the hood right, everything's it, and the ductwork is the one that ends up doing you in. I've been to several homes and everything's cool, but the ductwork doesn't work properly. Everything is in the duct run is going to affect how well a hood's going to be able to perform. The size of it, the shape of it, how long is it, how many turns it's there. When you're helping somebody plan and lay out a kitchen thing, I have seen plans where I'll look at with somebody and go, well, how are you going to run the ductwork on this? It might be in the middle of the house. And they go, well, we're going to go up, then we're going to go over about 10 feet. Then we're going to go down. We're going to go through the basement. Then we're going to take another right turn, go up to the garage, go back up and go through the roof in the garage. It's not going to work. There are limits to what these things can do. Just because you can route ductwork doesn't mean it's going to work. So what do you want to do? You want to keep it short and straight as possible, and you never want to restrict the duct size. In other words, reduce it, which is counter to how an HVAC guy is going to look at it. Because when they run their ductwork, they're not dealing with this high velocity that we're talking about. Even 300 CFM is a high velocity compared to what's running through your furnace ductwork. What they will do is they will actually reduce it the further it gets away. What we want to do is enlarge the duct the further it gets away, because we don't want resistance. We don't want to choke it off. If you see up there in the upper right, an 8-inch reduction to 6-inch actually reduces the volume that duct is able to handle by 53%. So that can negate a lot of what a duct is doing. Obviously, they seal all the joints with heat tape. You really do, and this comes with where you're routing it and replacing the cooking equipment and how you can run the duct. If you're going to make turns, you want to leave space in between them. And when you do them, you need to be smooth and gradual, because air is very dumb. It won't make, if it runs into a wall, if it has a right angle that it just bumps into, it doesn't know where to go. It doesn't look around and go, oh, there's a hole above me, I'll go up there. It just runs into it and starts rolling around, and then it can come back down the duct run. And there are tools to help do that. Here's some good and some not good. Flexible ductwork is, I see that a lot. It is problematic. It's like putting a speed bump on a freeway. even though it doesn't seem like it, and it's really easy to bend and move that around an obstacle, it does slow down the airflow a lot. So we want smooth walled duct. When you make a turn, you really don't want to make a sharp angled turn for a right angle. You want it to be a smooth, gradual turn. Think of, again, on the highway, if you come up to a turn, if you're going 60 miles an hour, they don't put right angle turns on the freeway for a reason. You're moving too fast. You're going to crash into the wall. Air does the same thing. Combining two ducts is tricky, but there are things out there, transitions like you see in the top, that will properly combine them. It puts them together, gives them an angle, tells the air right where to go. Scenarios like the bottom right, I have seen, and what happens in those, the air runs into something, doesn't know where to go. It rolls all around. Sometimes it might come down the other duct on the left or the duct on the right. Really does not work. So running the duct properly is very important. And a lot of times people just don't, and they don't think about it. Very, very clever here, especially the one in the middle. I think most people who don't know duct work would look at this and say, that's not going to work. And here you can see where they've reduced that. That's really going to very negatively impact the ability of your hood to do its job. This is what we want. We want them to go nice and straight, nice gradual turns. Frequently, it is easy. You don't run into too many issues with seeing where the duct can go. Again, unless you're in a condo or a shared wall scenario, that's where we have the duct-free hoods. But that's where we're going to wear them. Another installation that is tricky sometimes is island hoods, because island hoods have weight to them. We're not able to put them into a joist on the wall. They're going to need to attach to some sort of structure above them to hold the weight of the hood. So that's also important to pay attention to when you're going to do a large island hood. And if people go to look at how you're supposed to install hoods, they will find bad ideas on the web. I mean, this is stuff I found when I just did, how do you properly install a hood? How do you properly run ductwork? The one on the left is from a hood manufacturer, and it's got like 12 things wrong on it. Well, there's 9 numbers. So all 9 of those things are wrong. That is not going to work very well. So here we're going to get to the fun part. This is what everybody is on the edge of their seats to talk about, because we're in Minnesota. We're talking about makeup air. It's the elephant in the room in Minnesota. And the reason I call it out as in Minnesota, there are makeup air codes in more and more states. This was from 2012. Many more states have started to adopt what they call the national code. And here's where we'll get into what that is. So nationally, they're wanting you to put in something to make up the air your hood is pulling out of the home if you are moving more than 400 CFM, 400 cubic feet per minute. Minnesota is very different, and they got on this very, very early. They've adopted a much more strict code than the national code, up to 300 CFM. And if you guys have probably experienced this at some point, you really don't need to worry about anything. Go ahead. Once you get above 300 CFM, you're likely going to be needing makeup air. And this is the inspector is going to tell you, you have to put this in. Certainly, if you're over 600 CFM, you're going to need makeup air. Now, even though Minnesota's version of the code doesn't require the makeup air to be tempered, which actually means heated, pretty much everybody is requiring that now. They have decided, and in a minute, I'll show you why they're actually correct. You want to be able to heat up the air before you bring it in the house, especially like what's coming up this next weekend. You really don't want to pull that in. And the problem comes from this, and this is on the extreme end, but if you're dealing with any higher end clients or somebody who just is a really big cook, this commercial style cooking requires really high exhaust rates to deal with. Here we say the high heat volume, but also the type of cooking that they're doing. And today's homes are built keeping everything in. We're very tight where, if it's down in Texas, they want to keep their cooling bills low. Up here, we want to keep our heating bills low. So you put even an existing home, a house in South Minneapolis, it might be very leaky right now. Well, I go in and I put in new windows and I re-insulate the whole thing. I'm going to tighten it up. Newer homes, the holes that are through the wall or penetrations are mostly there to exhaust things out. And this is where the issue comes in. If we're pulling a lot of air out and we're not dealing with pulling it back in, we get negative pressure. And this is why it's in place. And Minnesota, again, got up on this very early. It's a good idea because you don't want to backdraft gases like carbon monoxide back into the home. That's why the makeup air requirements exist. And with homes getting tighter all over the country, that's why we're seeing more and more states adopt the national code. Again, here, we're very unique and very special. That's why it's you don't see a lot about it. Minneapolis metro area, we're dealing with this 300 CFM threshold all the time. But the solution is simple, right? Open a window. Honestly, that works. I have been in homes where they don't think the hood is working. This actually goes back quite a ways, but you crack a window and all of a sudden the hood works fine. Well, the home was under negative pressure. That's what the issue was. The thing with the code is we're not going to trust you to go open the window. So what we want to have happen, and by we, I mean, the state and the inspector and everybody who doesn't want carbon monoxide in the house, they want it to happen when you turn the hood up above 300 CFM, basically. They don't want it to be passive. They want it to be active. So when I turn the hood up, we want to pull it in. But here, we don't want to pull in minus 18. If you're pulling 400 CFM of outdoor air and it's 5 below into the home, that's not very good and very practical. So the best solution is what they're requiring you to do when you have to deal with makeup air here, which is put in what they call a tempered system. And here's an example of kind of where that goes in the house. It's usually going to have a piece of equipment, a makeup air unit that's going to pull air in from the outside, and it's going to equalize the pressure up in or in an attached room where the offending appliance is, which is going to be whatever your cooking equipment is. And it's going to temper that in. If the air is cold, it's going to bring that temperature, the air temperature up, so we're not dumping that into the house. And they can get expensive. And this is where a lot of the issue comes in for people. This is just one example of a makeup air unit that's out there. This is just the equipment. Now we have to install it. It needs an 80 amp it needs 80 amp power down. We don't have that. A little bit easier to plan ahead if you're doing a new home from scratch or a massive remodel. To be fair, there are some homes like, again, South Minneapolis, there may not be space to put all this stuff. I also have to put another hole in the wall. Where am I going to put that? I know there are requirements on how close you can have holes through the wall. So it is a conundrum. We're very lucky in Minnesota that we get to be really smart and clever and figure out how to deal with this because we deal with it here more than literally anywhere else in the country. And this adds to our conundrum of how do you design a kitchen and you do it with good ventilation. Now, most people don't value it very much. And what they're thinking about when they come into choosing a hood most often is just, what does it look like? I want something that looks really cool, because it is visual and some hoods do look really cool. Now, on the other end, when somebody gets a call because something isn't working right, or they stop using their range hood, it's because it's loud. That's a big one. Sometimes it just doesn't work very well. Well, it's because they're not turning it up, perhaps because it's so loud. But again, they have chosen it on how it looks. Casey, see your question. No, actually not. It is a separate system. I frequently will hear somebody say, let me get back here. Somebody will say, I'm going to go back here. They'll say, oh, we put in an air exchanger, so we're good. That's not the case. It is a separate system and it's tied to the hood. So let's just say I have a 2-speed fan that's 300 and 600. At 300, nothing happens. As soon as I turn it to 300, it sends a message down to the makeup air unit to turn on and start pulling air in. So it is different than the air exchanger. It is not tied into that system. It runs on its own. So they love the way it looks, but it's very loud. I highly recommend any chance you get, go turn on some hoods. And if you get to an appliance store, or even your house, turn them on, just listen to how loud they are. We like to put numbers to noise. Noise is different for everybody. I play in a band. Loud to me is different than it's loud to even my kids, who always tell me to turn it down. And it's very subjective. So what may not be loud to somebody is too loud to somebody else. So obviously you want to turn them on. You want people to hear what it sounds like. But we do numbers for noise and ventilation. Ventilation uses zones rather than decibels. Zones are a little different. 4 zones is twice as loud as 2. Whereas on decibels, once you get up in the 80, 85, you start quickly doubling the actual noise level that you perceive. And here's just an idea. Engineers hate this. You can't really do this, but I did anyway, where you compare zones to decibels. The key is once we get at or above 70 decibels, which is equivalent to 8 zones, now we're competing with speech. That's why people don't want to turn their hoods up. And I get it. If you're in there and you're trying to talk to somebody, that hood has got to be moving air a lot, especially baffle hoods. Those things, when they're running at 1,000 CFM, are loud. We're getting up over 11 zones. Some of them are at 15. So now we're just at a point where conversation just is not going to happen while it's fired up. So people will turn the speed down, and then they don't capture everything, and then the smoke alarm goes off. So, but how do you choose? So how do you do this? And more importantly, for people in our industry, how do you advise a client on, like, where should the hood go? What type of hood should it be? Again, with CFM, good start is obviously the cooking equipment. And again, it's tied in directly. The ventilation equipment is just as important as what the cooking equipment is. So we start with that. What is it? I can look at plans. I don't have to know what model's going in. I'm telling you, if I see a 48-inch rectangle in the kitchen, I know something pro is going to go in there. I know that ventilation is going to be something we want to cover. I like covering it early so we can make sure that we're all on the same page on how we're handling that. But again, the lifestyle is important. How do they cook? That's really important. And when you're designing a home, there's a lot of lifestyle questions that come up. Are you vegan? Do you do rasher or bacon a day? Are you doing pro? Are you going to use a grill inside? Do you watch Guy Fieri all day? And I'm going to go to town on this thing. I'm building my dream kitchen, finally doing it right. I'm dropping 60, 80 grand in my appliances because I'm going to do this kind of cooking. Or is this the range the caterer told you to get because you actually don't cook? People come in and we need to put full sheet pans in. That's why we have a big range. And to be fair, a lot of people don't cook. They just order out, especially in the days of COVID. That's getting to be an even bigger thing. But important to know, what is your customer's lifestyle? How are they going to use this? Because that's going to affect what do we have to talk about around makeup air. Again, if I've got a 48-inch range, I really should have really good ventilation that's going to move a lot of air. But here in Minnesota, we're pushed to undersize it. And what happens when you do that? Because this is the other, this happens a lot. People just, it's too expensive. Maybe they can't put the makeup air in because they're remodeling that old home in South Minneapolis. But we're really taxing things when we undersize or underpower the ventilation. And when I say undersize, I mean putting a 30-inch hood over a 36-inch range. Seems like a bad idea. I have seen it done. And this is kind of what it's like to me. It's like if you're out shopping for a big SUV, part of what you want to do, but it's only twice a year, is you want to haul a boat, and you live in town, so you're not on the freeway much. Well, there's a $5,000 upcharge if you're going to go to the engine that lets you haul a boat and go over 70 miles an hour. But you're only going to haul the boat twice a year, and you really don't drive over 70 very often. So do the 4-banger, you'll be fine. Are you? I mean, the day you go to haul your boat, you're going to be kind of mad, or you're going to trash your truck. So a lot of times this is the conundrum. You know, a 48-inch range costs about 15 grand already. If you're doing a big project, that, you know, the price tag for that thing can be pretty significant. People frequently buy this stuff because they want to use it. And 3 years out, what are they going to remember? Are they going to remember what the whole project cost? Or if because they saved money and undersized and underpowered their hood to avoid makeup air, what are they thinking 3 years out? You know, I have this conversation with people. It's like, yep, If you stick at not putting in the makeup air, this is 3 years out. Ask yourself, the smoke alarm going off all the time, is that bugging me? Or do I love that my kitchen is working really well? How much, I don't even remember how much the makeup air was. Heck, we did a $300,000 remodel, let's say, or we built a $1.2 million house. What's the cost of makeup air if you can fit it in when you're dealing with something of that scale? So I think that that does play into it too. And as an advisor, it's important to inform your clients, I think, so they can make the decision. A lot of people go, that's fine. Smoke alarm goes off a couple times. I'm good. I really don't want to pay for that makeup air stuff. More often, people are investing in their home and they want it to work right. Because this will happen if you underpower your ventilation and if you undersize it. The picture on the left was a house I was at. They were like, hey, this really doesn't seem to be working very well. Can you look and see if they ducted this correctly? Oh, they did a good job ducting it, but it has only 300 CFM in it. Plus, the designer made a shift in the size because it would look better in the design she wanted to do. So it's actually 6 inches too narrow. We like to talk about planning for the worst day. This day everybody's over at your house. You're showing off in your new kitchen. You're going to town. You're doing Guy Fieri on the griddle. Is that the day with the smoke alarms going off? Probably not. So if we can plan for that day, we know that all the rest of the days when we're just boiling water is definitely covered. And bear in mind, this is tough because most people are here. I don't really care. What hoods don't work anyway. I don't want to spend a lot of money on them. Well, as you can see, you can do things that are going to work, but this is very valid that this is where their headspace is at. They really don't value it very much frequently. They've never experienced hoods that work. Sometimes they have hoods that don't work. They don't complain because it is meeting their expectation, which just happens to be very low. So this is the conundrum. When we're designing a kitchen and we're trying to provide proper and effective ventilation, we have this form and function thing that we've got to deal with. Remembering what this guy said, it's not just what it looks and feels like, it's how it works. Again, if it's not working, we're going to know. We're going to get smoke alarms. If it is working, we're going to know because that doesn't happen. I don't smell the bacon in my bedroom. And the hood styles can impact that a lot. One of the things I hope to help people get to is when you look at a hood now and think about how it's going to work. Downdrafts are out there. How much capture area does a downdraft have? None. It's got to move a lot of air to start pulling cooking vapors over. That's going to be loud. Air moving fast gets loud. OTRs, you don't talk about how well they ventilate much. There's a reason for that. They're very flat. Some hoods look really cool. That one in the bottom right is a really neat looking hood. You can see the fins at the top. It might be recirculating. What is the customer's expectation over that gas cooking equipment it has underneath it? It might be meeting it, even if it's not working very well, because they're cool with that. They don't need it to work well. But as somebody advising them, in my role, I feel it beholden to always point out how well it's going to work. And if there's something that works better, what is that and how much is that going to cost? Because there are some really funky hood styles out there. And I think most people can look at some of these, especially if you look at through the lens of Ventilation 101 and figure out how well they're going to work. I mean, the clock is a cool idea. I got to have a clock anyway, right? Let's throw a hood in the bottom of that. Well, it's not really going to work very well. Top left, some people get real clever. That's one of the more unique red-green applications of a built-in hood, maybe, I think. So, these are going to look cool, but think about how well they're going to work and what your client's expectations are. You put it in the wrong spot. This looks really good because everything's linear and it lines up on the plan. You stand in front of this thing, you start cooking and everything goes up and your kitchen gets hazy. I wonder why. So when you're in a planning stage, you really have a good opportunity to get these things right and avoid problems like this one. Because taking it back to the beginning again, the purpose of ventilation is this, that we're trying to increase this air quality by pulling these contaminants out before they mix with the rest of the air in the home. We're dealing with the heat, the steam, the smoke, the odor, hazardous gases, and we want to intercept, grab that grease, keep that from going through the house. Don't want it in the duct run, want to clean it out. Because this is what we want. We want the nice clean air. We don't want that London 1952 air. And here's all the things you do have to kind of deal with here. We've got aesthetics, covered that quite a bit. How does it look? Location, both in relation to the cooking equipment, but can you actually duct it properly? Are you asking the ductwork to do things it can't do? What is it going over? How do they cook? How important is air quality to them? Yeah, it's getting more and more important. You know, this asthma's up because our homes are tight. Dust mites are in the air, for example. In the kitchen, we have something we can do with that. And what are their expectations? They might be very low. They might not tell you. They might think that this 300 CFM fan in their hood that they're sticking with so they don't put in the makeup air is going to work just fine, because why else would you have told me to put this in or sold this to me? You have to make sure that their expectations are met. And sometimes you just say, well, to do a hood that'll work is, you know, the whole part of the project, that's going to increase the cost quite a bit, but we can do one that works. It'll just cost more money. You know, let them know that they can make the call. So wrapping it up, hopefully we got here with a lot of things through this presentation. Understanding basically ventilation. What is it? How does it work? When you look at the different types of ventilation out there, what can you realistically expect them to do? How well will they perform? What will they do? Putting the hood in the right spot and installing it correctly. What is the consequences of that? It's very impactful. And in general, and I always say 3 years out, somebody's standing in their kitchen. Are they loving their kitchen? Are they loving their kitchen, or are they getting a haze through the house every time they cook? 3 years out, that's what I want them to be able to do, to love their kitchen project, because it reflects on everybody, how well they did, how much they're digging it. If it's a dream kitchen, my goodness, yes, we want them to be able to use their $15,000 range. So thank you. Went a little bit over 1 o'clock, but we started late. Hopefully this was helpful and informative. We at Shady Oak are always ready to help answer your questions and concerns around ventilation, regardless of what they are. We have a lot of experience with it, and we want to help you get it right. So let us know anytime we can help. And thanks for attending the first NARI Lunchbox meeting. There
Thank
we
you.
go. Thanks, everybody.
What? Thank you. Have a good day, everyone.
Looking forward to seeing everybody in person soon.
Yeah, we'll see you at the next one. Thank you.
All right. Thank you.
Bye, everyone.